On the same page where we just finished disulfides and phosphorylation, I want to move on and talk about a very important topic. This may be the most important skill we learn in this entire chapter, and that is the process of peptide bond formation. Peptide bonds are going to be the links that allow amino acids to be brought together and made into proteins. So it's critical that we understand this chemistry. And it's not that difficult to understand, so let's get right to it. In order to link two amino acids together, we have to bring the carboxylate of one close to the protonated amine of another. And when we do so, we can circle atoms that add up to a water. Let's mark off 2 hydrogens and 1 oxygen. That's an H2 and an O. And we're going to take those away and connect what is left over. So I will go ahead and draw a bond between that carbon and that nitrogen. And when we do so, we end up with that bond right down here on the one below. So let's make sure we understand that that right there is the peptide bond. Now, notice something about this. It's an NH right next to a C double bond O. That peptide bond is the same exact functional group as an amide. Or an amide, sometimes we call it. And amides and peptides are chemically the exact same thing. You learned amides as functional groups, but we like to think of them as linkages. And it's really the combination of a carboxylic acid and an amine taking away a water. When I see an amide, I don't just see a functional group, I actually see a buried carboxylate on one side and a buried amine on the other. However, it is an amide. A peptide bond has all the properties of a standard amide, and the most important property about peptide bonds and amides is that they are always neutral. Amines can be positive. Carboxylic acids can become carboxylates and be negative, but once they combine to form an amide or a peptide bond, they are always going to have this particular neutral state. So that's a critical point, and what we have now done is created a peptide bond. We've brought 2 amino acids together and connected them, just like we would take 2 train cars and bring them together and connect them and make a train. So what we've created is actually referred to as a peptide. So the peptide bond brings 2 amino acids together. The resulting molecule is a peptide, and we would call this a dipeptide because this particular one has 2 amino acids. If we had 3, it would be a tripeptide, so on and so forth. So that's peptide bond formation. It's really all about amides, and we're going to do a lot to recognize those and to work through the amide chemistry. But I told you this is really important. It doesn't have to be hard. And we're pretty much done. So let's finish it by simply writing down that this process is essentially a dehydration where we eliminate a water. I got to warn you, that's not actually how it happens in the cell, but it's a good way to think about it accounting-wise and make sure that you have the right structure in the end when you combine these 2 functional groups.